So before squeeze theorem, we need to talk about this theorem. What it says. It says if f of x is less than or equal to g of x when x is near a point A, except possibly at A, and the limits of f and g both exist as x approaches A, then limit x approaches A f of x is less than or equal to, you see the same sign, less than or equal to limit x approaches A of g of x. Let us see what does it mean graphically. So suppose this is f of x, the graph of f of x, and this is the point A, and it says f of x is less than or equal to g of x, meaning g of x has to be above f of x, near A. So we can draw a graph like this. This is g of x. Now as you see here, so f of x is less than or equal to g of x of all the point near A except at A. Then what happens when you take the limit, as limit x goes to A, f of x is always stay less than or equal to the limit x goes to A, g of x. Squeeze theorem, it says if f of x is less than or equal to h of x, and which is less than or equal to g of x when x is near A except possibly at A, and the limit x goes to A f of x is same as limit x goes to A g of x, and which is equal to L, then limit x approaches A of this one, the middle one, h of x, should also be equal to L. Now let's look at this situation graphically. So here f of x is less than or equal to h of x, less than or equal to g of x. Near A, f has to be the below g and also below h. H has to be in the middle. So we're going to have a situation like this. Something like this. This is h of x. So as you see here now, as x approaches A, like always, if this one, if fx is approaching L, suppose L is over here, and g of x also approaching L, then the middle one, h of x, also must approach L. So it says we want to use squeeze theorem to prove that limit x goes to 0, x squared times sine 1 of x equal to 0. Now suppose instead we just try to use limit rule. So if I use the limit rule, I can write this is equal to limit x goes to 0, x squared times limit x goes to 0 sine 1 of x. As x goes to 0, x squared is clearly equal to 0 times, what is sine 1 of x? This is the graph of sine 1 of x, how it looks like. And as x approaches 0, this approaches infinity. And this is never-ending process over here, mean this does not exist. So we really don't know the answer right now. But if you look at sine 1 of x, it is always between -1 and 1. That is always true for any sine function. Now, we can multiply this equation, inequality, by x squared, because x squared is always positive. So when we multiply, the sign won't change over here. So you get x squared times -1, you get a negative x squared, less than equal to sine 1 of x, sorry, x squared times sine of x, less than equal to x squared. Now if I take the limit, x goes to 0. So on this inequality, x goes to 0, negative x squared, less than equal to limit x goes to 0, x squared times sine 1 of x, less than equal to limit x goes to 0, x squared. So we get over here x goes to 0, this is equal to 0, and this is also equal to 0. That makes that limit x goes to 0, x squared times sine on x between greater than equal to 0, also less than equal to 0. Therefore, by squeeze theorem, limit x goes to 0, x squared times sine 1 of x equal to 0. Now, if you want to see the graphs, actually, you can see here, we know the graph of x squared. X squared is a parabola like this. And the negative x squared is a graph, the opposite graph, mirror image around x. This is negative x squared. So x squared times sine of 1 of x is going to be a graph like this. Let's look at this example problem. If x to the third minus 7x plus 6 is less than equal to f of x, which is less than equal to x plus 1 to the fourth power plus 12 for all x. And then we asked to evaluate limit x goes to -1 f of x. Now, we don't know formula for f of x or a graph. Only thing we know is it is in between two different functions. Therefore, we just have to get the limit as x approaches -1 of the left and also of the right, and see whether they are the same. If they are the same, then according to squeeze theorem, we can get the limit x goes to -1 f of x. So limit x goes to -1, x to the third minus 7x plus 6. So we can just substitute the -1 over here. So you get a -1 to the third power. This is the polynomial function. So -7 times -1 plus 6, which is equal to -1 plus 7 plus 6, which is equal to 12. And the right hand side one, we're going to find the limit x approaches -1, x plus 1 to the fourth power plus 12, which is equal to, as x approaches -1, we get a -1 plus 1 to the fourth power plus 12. This is 0, so therefore this is equal to 12. So what you got is, as x approaches -1, left hand side goes to 12, and the right hand side also goes to 12. Therefore the middle f of x has to go to 12 by squeeze theorem. So that means as x approaches -1, f of x is equal to 12. Now let's look at this example problem. So we are asked to use the squeeze theorem to prove that limit x approaches to 0, x times cosine 1 of x equal to 0. We know that for any x, for x is for any x not equal to 0, x times cosine 1 of x, the absolute value of that, has to be less than equal to absolute value of x. Let's see why it's true. Here's the cosine function for any cosine angle. What we know, the cosine has to be between -1 and the 1. So this part, the cosine 1 of x is between -1 to 1. So you're multiplying by a number between -1 to 1. The x is multiplied by a number between -1 to 1. That guarantee that it's always less than equal to absolute value of x. Therefore, now we can simplify this one. This is equal to x cosine 1 of x has to be less than equal to this one, but greater than equal to negative of that. Why so? We know absolute value of anything. Suppose absolute something is less than equal to 2. What does that mean? The something has to be less than equal to 2 and greater than equal to negative of that thing. So that's what it happens. Now, if I take the limit as x approaches 0 of the left hand side, negative absolute value of x. As you see, as x approaches 0, this goes to 0. And also if I get the limit as x approaches 0 of the right hand side, which is absolute value of x, this one also give you 0. So therefore by squeeze theorem, the middle has to go to the same value. So therefore by squeeze theorem, what we get is limit x approaches 0, x time cosine 1 of x has to be equal to 0.